Okay, lecture 42, Hypothesis Testing for a Mean, Basic Ideas, Part 1. All right, I've already kind of introduced the idea of hypothesis testing, but I haven't done it formally. I haven't put up all the notions you need to fully understand how to think about and work through a problem because I was trying to give you an intuitive idea. We are now going to, the next couple of lectures, just kind of go through all the basic ideas and basic definitions and notation that we're going to need to be able to perform hypothesis testing, to work problems in hypothesis testing. We're not going to do I'm not going to do a lot of writing, actually, very little writing. I'm going to just put some things up here for you to copy down in your notes. And if you follow along, you'll see the spaces where you need to write things down. But I'm not going to be spending a lot of time writing. I'm just going to put them up. And so you're going to have to pause me quite often, I think, to fill in the sentence or fill in the paragraph, all right? But these notes are essential. Once you get the notes for this lecture and probably the next lecture filled out correctly, you're going to want to set them off to the side to refer to them while you then work through the examples and the problems that we're going to do later, because all the ideas will be there formally and you'll be able to see how they come together in the working of problems. Okay, so, excuse me. What's our context? Our context is that we have some population of data with a particular population mean mu sub 0, I say here. Typically, in mu sub 0, remember that was kind of our starting mean that we think of initially as the population mean. Typically, there'll be some change that we introduce or that happens naturally that may affect the population as a whole, therefore it may affect the population mean. Okay? And what we want to do is test as best we can whether a change actually occurred or would occur under the new circumstances. All right? That is, we want to test whether the population mean mu is or isn't still the original value mu naught after the change happened, if there was some kind of a change, okay? So that's what you need to fill in the first blank. So what that really means is, does the population mean change or doesn't it? Really, the way to think about it is that's two conflicting conjectures or statements or what we call hypotheses. We want to test two conflicting hypotheses, and we can just state them kind of generically, like one hypothesis is there was no change versus the other one, which is there was a change. All right. The no change hypothesis is called the null hypothesis. Null for no, for nothing. It means nothing happened. All right. And so we denote that by H sub 0. H for hypothesis and sub 0 is 0, null, nothing, right? Okay, so what we have is, and this is how we would state it generically, we would say H sub 0 colon, I'm telling you H sub 0, my statement, my hypothesis is no change. This new population mean mu is just the old one, mu equal mu 0, all right? The alternative hypothesis, if you're following along, it's denoted H1, and that's the hypothesis that there was some kind of a change. All right. Well, this can take on one of three different forms depending on what we are testing. And so you have space there. First, maybe what we're testing is whether or not the mean increased. Did what happened cause the mean to increase? Do we think it did? In that case, we have as the pair of conflicting hypotheses the null hypothesis that mu is mu naught, no change, and the alternative one is that, well, no, mu got bigger. Right? We could be testing whether or not the mean actually decreased because of something that we did or something that occurred. So if we're testing whether the population mean, I should keep emphasizing, we're always talking about the population. Did it change? In other words, did the population mean change? So if we're testing whether the population mean decreased, we still have always as the null that mu equals mu sub 0. No, there was no change. And the alternative then is, it actually did decrease. Okay, well, perhaps what we're interested in is just whether or not there was some change in the mean, all right? Did the mean stay the same, or did it change one way or the other? In that case, the null hypothesis is still mu is equal to mu sub 0, but now the alternative one is just no, mu has changed. I'm not claiming necessarily it got bigger or smaller, just that it is some different value. Okay, 3 examples should make this a little clearer. All right, so I'm on to the examples now here. So the first example I have, and this comes from lecture 41, the tomato plant example. So if you want, you can go back and review that one, or at least review your notes, which should help you remember what was going on there. So I'm going to state this as a claim. In fact, this is typically what happens in hypothesis testing. You have some claim you're trying to establish as being true or false. And here's the claim. This new fertilizer will increase average pounds of tomatoes per plant to be more than the current yield of 12 pounds per plant. All right, there's a lot of information in there. If you go back and review that example, you'll see that we are capturing the essential question, right? We introduced this new fertilizer. It was the case that in the population that we had, or that we still have, the yield per plant averaged 12 pounds. Now, if we were to introduce the new fertilizer, would that change the population and give us a population mean greater than 12 pounds? And we talked about taking a sample and working through whether or not it did. And we're not going anywhere near that far right now. All we're trying to do for now is see how we set up the formal problem. And that is, first thing, we have to decide what is the null hypothesis, what is the alternative hypothesis. And typically, and this is a good example, in the claim itself, you can figure out which hypothesis is being stated explicitly. And notice what it says. This new fertilizer will increase average pounds of tomatoes to be more than the current yield. So the words increase and more give the hint we need. What's actually being stated here is the alternative hypothesis, right? The mean's going to get bigger is what it's saying. And so it involves the notion that the mean will be bigger. So I can now frame the problem in terms of 2 conflicting hypotheses. The null hypothesis is that, no, mu stayed the same, 12 pounds. That 12 is now the mu naught, right? The generic mu sub 0, that's our starting mean. So now we know the number is 12. But the alternative hypothesis, the thing that's actually being claimed up here, is that, no, mu got bigger, right? So what we have done right here is stated our conflicting hypotheses. The work that we do from here on out is based on this. And again, we'll get to all that, get to how to solve the problem formally, but we have to first understand this is how we frame the problem in terms of these conflicting hypotheses. Okay, what's the second example? The claim is that 2 months after a certain type of tumor is initially discovered in a patient, it averages 3 millimeters in diameter. This new drug will shrink the size of these tumors during those 2 months. Based on this statement, can we figure out what the null and alternative hypotheses are? Well, the word shrink is certainly the key. We're saying that we think the mean will get smaller. And in fact, then that's it. The null hypothesis is still that mu is equal to this mu sub 0, 3, which is, what we started with, right? That's my mu sub 0. And what we're contrasting that with is, no, we think that we're going to be able to show that the mu actually is smaller, okay? So in both of these examples, you have one claim, right? In the first one, it was the yield's going to increase of these tomato plants. And the second one is the tumors will get smaller. You need to think about what that's saying and figure out from there that there really are 2 conflicting hypotheses. The null one that keeps things the same, and the alternative one. And what does the alternative one say? It says, no, the mean got bigger or smaller depending on the language. Let's go to the third and final example I have. The average age at which a child first begins to read is 5 years and 4 months. Notice this really is just a statement of equality, isn't it? The average age at which a child first begins to read, and you may remember like from algebra class, you see the word is, that often means equals. 5 years and 4 months. So in the previous 2 examples, change or some indication of inequality was explicit. meaning we were actually seeing the alternative hypothesis. And this is what you need to have down, that we saw originally the alternative hypothesis. Here, what we have is it's just a statement of equality. We're actually seeing the null hypothesis, right? So this is an example where I'm not questioning whether or not something changed. I actually have an initial opinion about something. I think the age at which a child first begins to read is 5 years and 4 months. And the question now is just testing whether or not that's a correct opinion, right? So I'm not looking at a change coming into play. It's just whether or not I should change my opinion, really, okay? So what do we have? The null hypothesis will be, and I think I changed this to be in terms of months. 5 years and 4 months is 64 months. So the null hypothesis is mu is 64 months, right? What is the alternative hypothesis? I'm not trying to claim it's greater than 64 months. It's less than 64 months. I'm claiming it's equal, which means that's the null that's actually being stated explicitly, and the alternative must simply be, well, no, it's not 64 months. Maybe it's greater, maybe it's less. Nothing in this claim gives me a reason to say that this should be less than or greater than, right? I only have this, so my alternative just has to be it's not equal to. Okay. And I think we'll stop there. I do want to point out that the sentence there at the bottom of your notes, note, in each case, the null hypothesis is the one that contains equality. The alternative hypothesis should never contain equality. It should be a strict inequality. It should be greater than, or less than, or not equal to, right? It should be greater than, less than, not equal to. That's the alternative. The null, H sub 0, should always contain equality. That's something to keep straight in your head. It will help you do things right in the future, all right? All right, we'll stop there.